next one I should be saying?
Anyone want to help me out?
All right, so
You set
So-
the KVP.
Let's do it
KVP.
one at a time, okay? Have him first, and then you,
Okay.
okay?
All right, so she turned on the main switch, right? And then set the KVP, which is auto transformer, which is the first induction. And then after that, the KVP will flow into this one. What is this called? Kilo millimeter or whatever. It'll be still 110 volt, right? And then after that, the electricity will flow.
Okay, hold on, I'll stop you. Your meaning is right, but the way it was presented, it's different than what I need. So you set your KV. Kilovolt meter will read that setting you had, and then will tell this hand to move here.
Oh, okay.
At a dial.
Yeah.
Oh, so we have to say that.
Set your
Kilovolt meter.
Set your KVP
Will.
and then the
Will.
kilovolt, and then the
Will.
kilovolt meter will tell.
Other thing
set
I
the
noticed yesterday, no one recorded.
I
Every group,
almost did.
I wrote it
Pass me
down.
my phone.
every
Girl
group,
fighting.
Vince, are
You got
you?
it?
phones
are you
were like
recording
in
this?
front of me.
Hold on, let me record this.
Yeah,
Just to
someone
make sure.
It's Candy Crush.
I'm new to this phone. I'm trying to find my recorder.
Trying
to find a record.
Electricity flows and warms up the
Shut up,
too.
dude.
It looks
He
like,
has it, he'll just send it to us.
it looks like the handout from yesterday.
There we go.
So the anode side and then.
Alright.
Alright, who's next?
You start.
You are.
Me?
Yep. So that's after his first induction.
Alright, so 60 hertz is the outside current. It's 220 to 240, gets converted by the transformer to 110 volt. Turn on the main switch, reaches the X-ray tube anode to warm it up,
What reaches there?
the electricity.
Okay, good.
You set your KV on the main circuit. KV meter picks it up and sends the signal to the auto transformer to switch the KVP. Same thing that happens to the filament circuit. You set the MA, the filament ammeter reads it and sends it to the variable resistor and sets the MA. When you set
Fire the exposure, isn't it? Now, we're ready to fire the exposure, isn't it? Because you had the KV
And
and
the
the MA set already.
You haven't set
Time
the
to
timer
do the
yet.
exposure.
So you need to
The
set the
time.
you need to set
Okay.
the timer. It's the bridge.
Explain this one now.
Okay, you set the timer, which controls the exposure switch, tells it how much time it will turn both of these on.
stop set.
How much time you're
How
supposed to
stop
hold
it.
it?
Remember?
Yeah.
The when you hit the exposures, it will go down like a drawbridge. Now for
And when it hits enough KV and mass, and then it hits the beep, then it goes.
no.
back. Oh.
When you have the time that you set, the 3 seconds. that
Uh-huh.
You hold it down for
That's
3
what
You hold it
we
down
count.
for 3
Time.
seconds.
And then you hear the
Okay,
beep.
and then we'll go
And then
up
it
again.
cuts it off, right?
Yeah.
Okay.
Okay, that's what I'm just missing there. Okay.
All right. Once that's done, on the main circuit, the 110 volt will pass through the step-up transformer and gets converted to 10,000 volts, which is measured by the MA meter. And then it flows through the rectifier. No? Capacitor
importing those
first?
generators.
Okay, so the current is held in the capacitor, which is released by the falling load generator to the rectifiers.
Now, what if there was an error? We received 15,000 volts. What
Then
happens?
the excess will be held by the ground,
Okay.
um,
But the remaining electricity, what happens there?
just remains
Just circle around here.
Yes.
around here.
Yeah.
Okay.
15,000 will be stored here, but the remaining, isn't it continuously flows?
Right, right, right. So it's
That cut
continuously.
the remaining will just be circulating here over and over.
So if it's 15, and then it'll have 10,000 here and 5,000 will be circulating.
Yeah.
No, all the 15 will
Whatever
be still
that's
there.
left.
Will be on the ground.
Oh, okay.
We're talking about
Oh, ground.
from this line up to that line, okay, of electricity will just be stored in the ground. Now, from here, towards the remaining at the back will now be circulating around
Okay.
over and over.
Okay.
So when, let's say 15 is in here, when 10 goes out, 5 remains, and then it kind of refills it, or?
No, just 15 will be stored here in the ground.
Okay.
15 will just be stored there. Because the thing is, one thing will happen there, the machine will now stop working. It's broken.
Oh, okay.
That's why, so what, if we have 15,000 there, that 15,000 is just there.
Because
So-
from there, it's already broken.
So it's broken.
Because
It's broken now.
when
won't
the
work.
ground has to go
To do-
in, then it's broken.
It's broken now.
So you're saying like, if the fallout generator, drop more than, let's say 30,000 volts, let's say.
That will never happen.
Oh, it won't?
Because if that will happen, this ground will stop it already before that happens.
Oh, okay.
Ground will stop everything that's
So
wrong.
we'll only,
that's happening.
it will only get 15,000.
Yeah.
And then not, the
Ground
rest
is
will
before
just go
capacitor?
circle.
Mhm.
Okay.
So like even, not even before, like even the same, but the thing is, when wrong something like this, okay? Ground and then capacitor, okay? Something wrong happens, it will go here. Everything's okay, it will go here.
Oh, okay.
Oh, okay.
That's how it
It's
looks
like a
like.
funnel.
Mhm.
Cool.
All right. And then from the rectifier, it will go to the anode.
What does the rectifier do?
The rectifier.
Because
Change.
there's AC to DC.
Oh, there you
Uh,
go.
Pulsating
Pulsating,
DC.
sorry.
There you go.
Now, how does it flow?
Oh man,
Two ways.
there's two ways it
Highlighted
flows.
in there.
It goes like
Why,
this.
why did I show it to you if I'm not gonna ask that?
Really?
How do you think that?
This, and it goes here, and the other one goes opposite way, right?
Yeah,
Yeah,
it goes
it
everywhere,
goes
doesn't it?
up, and it goes
One comes from here, one comes from here.
Here,
Right?
Yes,
There's
it's
two
right,
coils.
right.
Got it?
Cause of the square,
the
right?
trick there,
It goes
follow
this
the
one,
arrow.
this one.
Follow the arrow.
Yeah,
So that
So
way.
one comes from here, one comes from here.
yeah,
Okay,
there's two
so-
So
lines.
like this.
So is that electricity?
And
This
then,
one is
like-
tricky.
Oh.
It goes here, and then you turn,
Top?
and then
Go straight,
you
straight, straight. Yeah.
turn, and go here, you go here, you go here, and go here, and go here, and
That's
go
just
here.
right.
So so
It's
in
really-
contrast of the color, what's the bright yellow representing?
The red?
The bright yellow, what's it representing?
Oh.
What kind of flow is that?
No, just the back and forth of this is one way to go there. the other
Oh,
way to
okay.
get
So we
there.
don't really need to name them. We just show the flow direction. Okay.
That's before it's converted, right? So is that because it's AC?
Yes, it's still
Okay.
AC, she's right.
So
Okay.
it's going
You
two
hear that?
directions.
So it's flowing here because it's AC.
Still
It's
AC.
going
And then once it
opposite
converts,
Still,
that's
still,
when it
still,
hits here.
still, yeah, when it passes there, it's still AC from here, not until it passes all
The
this.
rectifier.
Not
That's a
until
good
it passes the
job.
rectifiers.
Okay.
All right.
It only passes the rectifier to become DC.
Pulsating
Pulsating.
DC.
Yeah, pulsating.
Drill that into her.
I even bolded it too.
On the
Pulsating.
practical, when you say AC to DC, I'll just be quiet, I'll not say anything.
Okay.
But you'll see me writing there.
But then if we correct ourselves, that's still okay.
The what?
If we correct ourselves after, like, oh,
Oh, yeah,
no,
that'd
pulsating
be
DC
okay.
isn't- Okay.
Where are we now?
We're
We're on
rectifiers.
Okay, so.
After it passes the rectifiers, it gets converted to pulsating DC and then it's exiting out the anode side.
Okay, we're not done yet, is it?
Not done
You
yet.
guys agree?
The
Okay, good.
filament circuit, 110 passes through the step down, which converts it to 8 to 12 volts, and then comes out the cathode side.
Cathode.
Now, this is a question for Rick only, no one will answer this.
What?
How many inductions so far we have?
We have 6 so far.
5.
Oh, 5. Wait, hold on. So you get the first induction.
First.
The sixth
No, this is the
The,
first.
the
Second.
stator, the magnetic stator.
This is the second and the third, and then this is the fourth, and this is the fifth. Isn't it the sixth right here?
No.
Fifth.
The
These
step
are
down?
happening at the same time.
Right. The 6 is the stator.
Stator rotate there.
Oh, okay. So this is the
Rotate
fifth.
there.
Step up, transfer.
So from here, do you want us to explain the
Go on the
tubes
X-ray
also?
tube?
Or you want us to just label it?
No, no, we will
How do
continue.
we explain ball bearing and armature?
Oh, it's simple, isn't it? Okay, so what will happen now? The stator will
Spins.
have the rotor will spin because of the stator's magnet, which will be our sixth induction. And this is spinning. Now, when we hit the exposure, electrons will come out here. Everything will go straight. No one will go up there or down because it's guided by the focusing cup, which is
Negative charge.
negatively charged.
Yeah.
Now it hits here, the anode, which is ideally should have 12 degrees, and bounce out. But there's some neon gas also that guides them as they go there. But there will be some stubborn electrons that will be deflecting upward, which will be straying there, and might lead to rest on the walls, which would be R2 parking.
Okay.
But thing is, the X-ray photon will come
What I
out. That's
mean-
what they're
That's the
asking.
What about these envelope tungsten
We don't
anode? That's
need
what
a-
I mean.
You might still study the description
That,
of those. Because why is it that, I might ask you, why is it that, why did we use tungsten?
Because of the high melting point,
Of how much?
3370.
3370.
Oh, yeah.
And it's not easily
You made
vaporized.
me happy.
Not easily vaporized.
He's
It's
in front
high
of
heat
his phone.
conduction.
You have it on your phone.
Why, what is
It's a trend.
the focusing cup made of?
Nickel.
Ooh.
I don't have a problem. Okay? How about the base of the anode?
The face of this.
Oh,
written right there.
rubidium.
Molybdenum.
Mobidelum.
Yeah.
Molybdenum.
Molly wearing denim.
Molly wearing denim.
Yeah.
Okay now?
Yeah.
Yeah, that's how
Thank
it
you.
is.
You got it
Yeah,
all.
the more you explain.
Got it all.
Post it.
Type it all.
Put that on
Hey,
Facebook.
if you guys shut up, I might get it all, right?
You're still recording
Just
it.
joking. Hey, guys. I'm saying,
Hi.
there's Nickel guy over here.
This is 5 induction.
Dr. D. Oh, my bad.